All right, next slide, please. So that I like, it's just a reminder of the fact that a lot of what we do is at the crossroads of aesthetics and technology. So I wanted to bring to your attention, we have a new webpage for the San Diego Astronomy Association. That is, which you can find by typing SDAA into Google. And Dave, if you would put the link up in the chat. So for those of you who just like to cut and paste links into your browser, that would take you directly to our new webpage, and you can look around. A lot of hard work from Jeff Stevens and Hero, our two webpage creators. So, and if you've got that in the chat, then you can take us on to the next slide. Okay, so I wanted to encourage everyone to check out our YouTube channel, which is San Diego Astronomy Association. That's, you just type that in and that'll take you on YouTube, and that'll take you to our webpage. We have almost 72,000 channel views so far. And we have a number of our different creators of content providing videos into there. So I would encourage you to go there, subscribe, and that will shoot you little notifications every time we post a new video, which goes up every week or so. So yes, so thank you. So Dave has put the link to our webpage in the chat, and also if you can put the link directly to our YouTube channel, so you don't even have to type it in on YouTube, it'll take you directly there. And so I'll mention that we are featuring our recorded live stream of the 2020 planetary conjunction between Jupiter and Saturn. So we have a beautiful video done by our outreach people, recording that kind of in live, while streaming it out over, I believe it was streamed either over Facebook or YouTube already, but recorded and captured, so you can kind of watch the whole thing if you weren't able to catch it when it happened. So next chart, please. Okay, so first off, I want to remind you all that we have a Facebook, Twitter, and Instagram account, so you can go follow, friend us, and receive, we post our notifications for things like our meetings there, so you can keep up to date on what we're doing. And I also want to mention that we have a loaner program for telescopes. For those of you who may be new to astronomy, the club maintains a selection of telescopes which we loan out to people for a few months to try out and learn about it. And Dave has put the link in the chat right there. You can either go look it up on our webpage or copy that link out of the chat and paste it right into your browser address bar, and it'll take you directly to the area where are all the contacts and lists of the scopes that we have to loan out. And also I want to mention that we have a newsletter that we post every month. And if Dave, you will put the link to that up in the chat also. So you can either hunt around our webpage for it or copy that link out. And this month we have a great, lots of content in there, but particularly there's a nice one on navigating the mid-January night sky. So what's up in mid-January to look at, kind of thing. So, and there's the link for that, the January issue of our newsletter, which is all free. So next slide, please. So we have a merchandise store. So you can go to our merch store. Again, that's located on our webpage is the link that'll take you there. Or Dave will post the link into the chat for it, where we have merchandise like jackets and hats to keep us warm on those 49-degree nights that we have out here. We will also be using our merchandise store for our upcoming banquet, which we'll really kind of announce probably in a week or so with more details. So next chart, we have another video. If you'll run that video.
Traveling through the sun's blazing hot atmosphere, NASA's Parker Solar Probe has sent back a complex, close-up view of our star. The spacecraft confirmed that our picture of the sun from Earth is deceptively simple. Parker is the closest spacecraft to the sun, meaning we now have never-before-seen details about the solar wind and solar energetic particles. Solar energetic particles are high-energy particles that can endanger both astronauts and satellites in space. The solar wind is the continuous outflow of particles and magnetic field from the sun. Both speed out, filling up space, and affecting space weather throughout our solar system. For the first time ever, we were able to go to the source of the solar wind and solar particles. Here are 5 features Parker saw. We've long known that space is full of cosmic dust. We can even see the dust from Earth because it reflects sunlight. Parker saw evidence that the dust stops at an estimated 3.5 million miles from the sun. As the dust gets closer, the sun vaporizes it, creating a dust-free zone surrounding the star. At Earth, it appears that the magnetic field lines flow evenly out from the sun, but Parker saw them behave in a surprising way. The magnetic field lines flip in a whip-like motion, turning 180 degrees around in a matter of seconds. These switchbacks came in clusters and were timed with fast-moving clumps of plasma in the solar wind. Scientists have long wondered if the solar wind is generated as a continuous flow or in spurts. We now see evidence that the solar wind has rough, irregular texture. The plasma within it also seems to lack an orderly sense of direction. Some clumps of solar material fire out into space, while others fall back toward the sun. These clumps may be distorting the magnetic field, causing the switchbacks. They may also be an indicator of what the solar wind looks like in its early stages after its birth on the sun. Parker found a transition point in the solar wind. The corona is the sun's faint, outermost layer that transitions to the solar wind. Before Parker, scientists knew that the corona rotates with the visible surface below it, but they didn't know how, or where, the solar wind switched to flowing straight by the time it reaches Earth. Parker has finally spotted signs of this transition, and the changeover happened significantly farther out than expected. Although the sun has been very quiet over the first 2 orbits, Parker observed several tiny bursts of solar energetic particles. While these events have been seen before, never ones this small. The fast-moving particles from these modest bursts spread out as they move from the sun, making them undetectable from Earth. Without Parker's front row seat, we would never know that the sun is regularly producing these small-scale events. Fast-moving particles are a source of dangerous radiation. The more we learn about these eruptions, the better we can protect our technology and astronauts. Parker still has more work to do, but it's already helping us see our star in a whole new light.
There we go. There's a lot of scale of size that's just amazing and awe-inspiring. So when we look up at the night sky, several of those stars, Rigel, Betelgeuse, Arcturus, these are stars you can see with your eyes. And just to know how big they are in comparison to our sun or our planet is just amazing. So next slide. I threw in for our next slide a teaser for tonight's guest speaker, Maria Galloway Spritzma. And so I thought I'd put this in there and just make you wait after this to see her presentation. But I'm sorry, go ahead, Dave. On Pulsars, related to what the topic is.
A pulsar is a rapidly spinning neutron star, which is the small, incredibly dense remnant of a much more massive star. A teaspoon of matter from a neutron star weighs as much as Mount Everest, and a neutron star is so compact that a ball about 15 miles across contains more matter than our sun. Neutron stars spin between 7 and 40,000 times a minute and form with incredibly strong magnetic fields. Rapid spin and intense magnetic fields drive powerful beams of electromagnetic radiation, including gamma rays. As the pulsar rotates, these beams sweep the sky like a lighthouse. To a distant observer, the pulsar appears to blink on and off. Pulsars slow down as they age, but some of the oldest pulsars spin hundreds of times a second. Each of these millisecond pulsars orbits a normal star. Over time, the impact of gas pulled from the normal star has spun the pulsar up to incredible speeds. This accretion may be the cause of their weaker magnetic fields. Despite this, these pulsars also emit gamma rays.
All right, so that's just a teaser. You're gonna have to wait for Maria's talk, but it's gonna be really cool. So Dave, if you can give me the next slide, and when you start, right after you start the video, if you can set it to repeat. So this is from, and I'll just kind of talk over it because there's no narration. This is from current NASA satellite Juno mission, which is looking at the interior of Jupiter, and they put this camera on the Juno satellite, which is called JunoCam, and it's really just kind of a throwaway thing, not the main mission, not even close to the main mission, which is a kind of a radar RF mission looking at the interior of the planet. But it generates such beautiful pictures. And this is called the Dolphin, because if you look right at the middle of the picture right now, there's like a dolphin that's looking down and to the right. And the colors on Jupiter, striking, beautiful colors. So I thought I would just throw this in there as something new and different to get you ready for some more photography. So Dave, you can go ahead and take us to the next slide. Thank you. So we have many, many very talented members, and some of which are like semi-professionals. And so this is one of our pictures from one of our members, Mike Chasen, who unfortunately I know is not here tonight. Thank you. And you can see the color filters that he uses. So this is a variant off of the Hubble palette using hydrogen alpha, oxygen 3, and sulfur 2 bands. And as you can see, this total exposure for this picture is around 18 hours. And I'm sure he spent about that much, if not more, processing the pictures after the collection. So, so this is one of those things where you take the great enthusiasm of a astronomer, amateur astronomer who works at the technology of understanding how to operate the telescopes and the cameras and the software, and then melds it with an aesthetic sense. Because when you do the processing on these images, there are many choices of how you set the software. Some of which, like PixInsight, which is one of the software pieces he uses, has just a bejesus number of parameters. You can select it. And many of these choices, you're not in the realm of right or wrong. You're in what I would consider artistic choices of what you choose to do. So I think that picture is just beautiful. And so now, if you'll take us to the next picture, which is also from Mr. Chasen. And this one is an object that many of you seen with your naked eye, the Pleiades star cluster. And you may not be aware that there's a nebulosity around the stars. It's quite dim. So you have to take still long exposure. So, you know, the star cluster itself is quite bright, but this is a 12-hour exposure on it. And that's necessary to get the kind of detail in that very dim gaseous nebulosity around the stars themselves in this cluster. So thank you from Mr. Chasen for both of those. And with that, takes us to tonight's digital door prize. So Dave, if you will put the link for this in the chat. I will encourage you all to do this. I'm going to explain this a little bit. So there's a satellite called the SOHO satellite, the Solar and Heliospheric Observatory, and it's currently operating, and they take regular images of the sun, and that's kind of what you see in that control window. And they hold those images in a little archive, and what you can do is if you go to that link, you can pick the color you want. So, and this is actually, you see inside the little window there are three white boxes at the top. The first one, you get to select the spectral band that the satellite takes in, because it takes it in a number of bands. You can, the second box is the resolution. So you can have a kind of higher resolution or lower resolution version of the picture. I find that low resolution is perfectly good enough. And then the third white box there is the date. And you can then select a date from as current as today, and you can go back but day after day after day and select a time frame, and it will build a movie for you. So you can watch the solar prominences and coronal mass ejections fly away from the surface of the sun, kind of in a little movie that you built. And so I really encourage you all to try it out. It's fun, it's cool, and you get to see kind of what's going on. Well, you could actually build yourself a little movie and let you watch what happened on the sun this last week. Or if they have some big event you hear about on the sun, you can go back to those dates and pull that and watch it actually happen. So that is tonight's digital door prize, is this address to the NASA site where you can build your own movie. So with that takes us to the final slide, which is the introduction of Maria Galloway Spritzma. And I hope I did that right, Maria. And she was our guest speaker for this evening, and she will be speaking on pulsar timing. So Maria.